Hello and welcome. In this section of machine learning, we are at first going to see what are different types of machine learning algorithms. Then after we are done with the types, we will see how the evaluation is done, the different cross-validation techniques, and then we will see different algorithms one by one. So now let's get started with the basics of machine learning. Let's first of all see the origin of this term of machine learning. Basically, this term was coined by Arthur Samuel in 1959, which stated that a field of study that gives computers the ability to learn without being explicitly programmed. Well, this definition was accepted, but it didn't gain any momentum due to the unavailability of fast processing machines and also unavailability of the data. Well, also let us take a look at what is artificial intelligence. Artificial intelligence is a science and engineering of making intelligent machines, especially intelligent computer programs. Basically, it is related to similar task of using computers to understand human intelligence. Well, AI does not confine itself to just methods that are biologically observable. We will see different applications in our machine learning sessions which will be implementing artificial intelligence. So what's the relation between AI and machine learning now? Machine learning algorithms are used to implement the ideas of artificial intelligence. Well, machine learning algorithms are basically based on mathematical methods meant to achieve the optimization that AI actually expects. Now, how are machine learning algorithms different from the algorithms we might be knowing earlier? Well, whatever will be your programming task, that's for sure that your programming task will be requiring inputs as rules and data, and will be expecting answers. Answers will be in the form of reports. Answers will be in the form of any other thing, like labels. Well, answers may be like which customer purchased, which customer didn't purchase. Customer made a sale of how many thousand rupees. Okay, can be the answer which can be expected. Okay, but you see, our machine learning algorithms require a very different set of inputs. First thing, data no doubt is required, as well as answers are there. Now, I'm going to explain you what is this data and what are these answers. Well, data is the same thing, but answers are basically the labels which are related to the data. And what is expected out of machine learning algorithm are the set of rules. Rules, sometimes explainable, many times not explainable. Now, we will see different approaches to machine learning and different approaches to generate different rules. Also, we are going to see different types of machine learning algorithms. Well, among these three types, we are going to see supervised learning and unsupervised learning in detail. Supervised learning algorithms are the algorithms which require one or more outcomes. Outcomes are basically the things which can be predicted. Okay. Now, they can be numerical or categorical. Well, say suppose that we have sales of any product. Now, business domain knowledge definitely tells us that sales depend on demand, promotion, and many other factors. Now, with the help of machine learning algorithm, we try to draw a strong link. We try to establish a strong mathematical link between the factors affecting the sales and the sales. There are various approaches which we are going to learn. Now, this is the case in which we have numerical outcomes. Such type of algorithms are called regression algorithms, which have numerical outcomes. Second can be the type when we want to predict something which is categorical. For example, a particular customer may buy a product, and the driving factors behind them, the buying, can be age, gender, or history of previous transactions that customer had, and many more factors. So we can build an algorithm which has a strong link between possibility of buying, rather we call it probability of buying. Probability of buying and other factors. Such type of problem is called classification problem. These are some of the supervised learning algorithms. We are going to see all of these algorithms. Next type is unsupervised learning algorithms. This type of algorithms discover hidden patterns or can do data grouping. And these algorithms don't have any outcome variable. Well, clustering algorithms, dimensionality reduction algorithms like principal component analysis, association rules mining, etc. can be the examples of unsupervised learning algorithms. Among them, in our syllabus, we are going to see k-means clustering algorithm. Now, third type of algorithms which I have mentioning over here is semi-supervised learning algorithm, which is a combination of supervised and unsupervised. In the real world, what happens is we get very large amount of unlabeled data and very small amount of labeled data or no labeled data at all. Okay, so what can be done is we can generate labels on the small amount of data and regenerate labels on the large amount of data. Generate labels on small amount of data by some other method and regenerate the labels by machine learning method. Well, there are some assumptions to the semi-supervised learning algorithms. One is continuity assumption, in which points that are closer to each other are more likely to share the label. It's just like a nearest neighbor kind of. Second one can be data tends to form discrete clusters, and points in the same cluster are more likely to share a label. Well, cluster in the same cluster, points will be having same labels. This is one assumption. Third assumption is data lies. Well, the data lies approximately on a manifold of much lower dimension than the input space which has been provided. Hence, we saw different types of machine learning algorithms. Well, the machine learning algorithm, when it is supervised one, it's very important to evaluate it. Now, we are going to see the different evaluation metrics for such kind of algorithms. Let's see them.